Dear students, in this lecture, we will study about polyphase circuit. Poly means more than one, so here we will go for three-phase circuit. We already seen in single-phase supply, we need pair of magnet and one conductor or winding that is rotating inside, and it generates single-phase EMF V equal to Vm sin omega t. In three-phase generation, we need pair of magnet and three coil, which is displaced by 120 degree apart from each other and rotating in a common magnetic field. It produces three voltages of same magnitude and frequency, but displaced by 120-degree electrical from each other. So here vector diagram is given for the VR, Vy, and Vb displaced by 120 degree from each other. So VR is reference voltage. So VR equation is Vm sin omega t, Vy that lagging by 120 degree. So Vm sin omega t minus 120 degree. Vb that lagging 120 and 120 240 degree. So the equation is Vm sin omega t minus 240 degree. Or we can also write for Vb in anti-clockwise direction. Vb is equal to Vm sin omega t plus 120 degree. Here three-phase waveform is given. Phase 1 starting from 0 to 360 degree. Phase 2 attaining its zero value at 120 degree. And phase 3 attaining its zero value at 240 degree. So this is the waveform of three-phase generation. VR, Vy, and Vb. Advantages of three-phase system over single-phase system. The first advantage is constant power. Since single-phase system, the output varies sinusoidally at a frequency twice the supply frequency. So this pulsating nature of current that is harmful to some of the applications. Whereas in balanced three-phase system, it supplies constant current at all instead of time. Self-start. In three-phase system, they are self-starting as they do not require any starting device or auxiliary devices. Whereas in single-phase system, it requires starting device. Greater output. The power generated by three-phase system is greater than that of single-phase system for a given volume and weight of the generator. More economical. The three-phase system is much smaller and less expensive than single-phase system because less material is required for a given output power at a given voltage. Less voltage drop. The voltage drop from the generator to the load, or we can say source to the load, is less in a three-phase system in comparison to the single-phase system. Power transmission economics, as we seen, three-phase requires less material, so there is saving in material, so there is strength of transmitting towers. High efficiency. So the three-phase motors are efficient and have a higher power factor than single-phase motors of the same capacity. Phase sequence. So phase sequence means the voltage or current attaining their positive maximum value in a particular order. The order in which voltage in the three-phase attain their maximum positive value is known as phase sequence. Generally, we are referring RYB phase sequence. Another phase sequences are YBR and BRY. Voltage and current relation in star connected system. So diagram is given for the star connected system. So all three windings are connected by one common terminal. So that terminal is called neutral conductor. So the EMF across each winding is called phase voltage. So phase voltage is denoted by ERN, EYN, and EVN. It is also called the voltage between any one line and conductor. So ERN is between line 1 and neutral conductor, EYN between line 2 and neutral conductor, EVN between line 3 and neutral conductor. So it is called phase voltage. The line voltage is denoted by VRY, VYB, and VBR. So line voltage is known as the voltage between any two lines. So VRY between line 1 and line 2, VYB between line 2 and line 3, and VBR between line 1 and line 3. IR, IY, and IB are known as phase current. It is flowing in each phase winding or each coil. Line current means